Okay. That was great. So now we're gonna try an experiment with three. So we're gonna have some guests sitting in the audience, but we're gonna have three guests connected from the internet in different parts of the world. So that's a bit crazy, but we're gonna try. So first of all, I'm gonna ask Matt Johnson to get on stage. He's the co-founder of Conductive. And then I will move on to introduce our online guests, starting from Leah Buechley, who is the, beyond a lot of other things, she's the inventor of the Arduino LilyPad, who actually kicked off all the sort of wearable Arduino movement. So thank you, Leah, for being here. I can see you. Hey. Hi, thank you. And we also have Giorgio Olivero. So Leah is connected from New Mexico. And then we have Giorgio Olivero connected from Hong Kong. Ciao, Giorgio. Is that like the middle of the night or something?
Yeah, we're getting close to midnight, yeah.
Ah, okay, that's good. And then we have Adam Benzion, who is connected from Seattle, if I'm not mistaken.
Yeah, hi, Massimo. Hi, everybody.
Hi, everybody. Wow, cool. So, and then we also have Andy Yell, who is joining us on stage. Okay. So this is going to be an interesting experiment, as I said, with people here in the audience and people connected from the three corners of the globe. So this panel is about makers, and actually what I'm interested in, I'm going to ask a few questions now to our guests. But the general idea is that, so when Arduino started, the maker movement was starting at the same time, and it sort of was like a magic moment where our tool kind of came to be known at the same time as this, say, movement started. And actually, the maker movement, I think, produced a lot of exciting results in the last, now, I think, 13-something years. But I think I want to have a short reflection with our guests about, the state of the maker movement, really, and what we think it's going to be the future. But I want to kick off, and actually I have a question for all the guests, which is actually, how did you become a maker? That's actually, I'm always interested in asking people how they got interested in making and what, how they became a maker. And so I'm gonna mix between the online guests and the live guests. So I'm gonna start with Leah, and so please tell us, how do you become a maker? And tell us a little bit about yourself. Just introduce yourself a little bit.
Sure. Maybe I'll start back at the beginning. For me, I grew up the child of hippie parents, I would say, in a very rural area, kind of up in the mountains of New Mexico. And my family always made everything. So my parents built their own house, and my dad fixed up the cars and was always kind of building things to add on to the cars to help us like get up our road and stuff. We had big gardens, and my mom always made food from scratch. So I feel like at the core, I kind of grew up enmeshed in a kind of maker sensibility. I should mention that what my parents also did professionally is they're furniture designers and builders. So I grew up, just really steeped in this kind of outlook on life. And I think for me, that's where everything really comes from. So more about me professionally. I am the developer of the LilyPad Arduino. That's been a really fun and ongoing project that I continue to be excited about. I'm also just more broadly interested in like art and design and technology and how those things can be combined in interesting ways.
Oh, wow, very cool. Yeah, I should mention the LilyPad Arduino has been amazing. The amount of people that actually approached doing projects with wearable computing thanks to the LilyPad is just amazing. So it's a great contribution to the maker movement. I'm just going to jump back to the live guests, well, the ones who are physically here. Not, we're all alive and live, but the ones who are physically here. So Matt, do you want to introduce yourself a little bit and tell us how you became a maker?
Sure. I think that the way who I am comes from how I became a maker.
Oh,
so
wow.
I think that I became a maker when I started disassembling a remote control car when I was a kid. But I'm sure as a lot of you remember the remote control cars that had a wire that were really disappointing because you had to walk right behind it. And I used to take it apart and not usually successfully put it back together. And I think that that was my first drive to prototype and play with physical stuff. But it wasn't until 2008 that I learned about Arduino. And until that point, I had no access to any sort of electronic prototyping, but I wanted it really badly. And I just had no one in my family that could give me any tools, no one in school that could give me tools. And as soon as I got my first Arduino, I dove in. And actually, since that, I've now started a company called Conductive that uses, we produce an electrically conductive paint and hardware based on Arduino. And that's what I do now. I think that is probably my favorite thing about the maker movement. 2008, I had absolutely no idea what I was doing, and now I'm running a printed electronics company. So that's the power of the internet and the maker movement, and certainly Arduino.
Wow, thank you. So we're gonna jump to one of the guests connected from the other side of the world, Giorgio Olivero. I will do a pre-introduction to Giorgio because Giorgio was a student in Ivrea when we were, even before we were making Arduino, when we were making the previous experiments that led to Arduino. So Giorgio was one of my guinea pigs and was subjected to some of the worst experiments that led to Arduino, and he's also the guy, the person who designed the Arduino logo and our sort of image. So he's, he's an extremely important person in the history of Arduino. But then, I'll hand it over to him and to introduce, a little bit about your background and how you became a maker.
Yeah, thanks. That's really a sweet introduction. Yeah, that's true. We were all of us, kind of 25 students, we are all kind of Massimo's guinea pigs. Yeah, the very expendable patient zeros. And some of us actually survived. And so, okay, going back to your question, how did I became a maker? It's one of the reasons why I enrolled in IDI, in the kind of design master where Arduino was invented, was actually to learn how to make stuff, right? I mean, I come from a family, as Leah just mentioned in those men, where, there was lots of makers, but, kind of the pre-maker philosophy, like, everyone would actually do stuff, their own thing in solitude, right? So there was no teaching at all. And so I was actually used to see kind of my father, my grandfather, and my great uncle, everyone actually engaged in doing stuff, repairing, taking apart things. No one would ever actually teach me anything. And so for me, and then at a certain point, actually, they weren't around anymore. And then I found myself, I said, okay, that's actually a broken link here. And so it was actually, for me, was such a kind of a huge kind of delightful moment when I got the chance to be a kind of a pre-Arduino user when it was kind of still a little bit harder and more kind of the guinea pig context. Yeah, so that was it. And then kind of 2 years of kind of design studies, and then other 10 years of prototyping, and now, yeah, I'm a designer, design director. I've been working with technology for basically most of my career. Yeah.
Nice. All right, so we're going to ask Andy to tell us a little bit about his background and how he became a maker.
Sure. So the story of how I became a maker is quite an interesting one. Both of my parents could not be more different. One is extraordinarily good at tech. The other one, thinks windows belong on a house rather than a computer. So with my father, he's always been in IT, and our sort of hobby when I was younger would be to get a desktop computer, get the components, a hard drive and whatnot, and install them together. He'd go through, he'd show me what to do, and as a reward, if you can put this all in and get it all working, you can have your pocket money. So that's where it all started for me. Now, my background today is I'm the supplier account manager at Premier Farnell, so I have a wide portfolio of suppliers. But the thing I love most about my role is I'm able to watch makers come together with a product, and I get to see that journey, help that journey all the way to market. And to help someone, to help a group of makers bring something that has been their absolute passion, their absolute baby to the world is absolutely phenomenal. And it's with things such as the Element 14 community and the help of companies such as Arduino that people in our space are able to share their knowledge. And at the end of the day, isn't that what being a maker is all about? Taking what you have and sharing it with the world. Cool.
Thank you. So last but not least is our friend Adam, who is also the co-founder of Hackster.io, which is also the platforms that powers the Arduino Project Hub, which is probably the best platform that people use to share tutorials and projects, and he's a great friend of Arduino and the community. So Adam, tell us a little bit about your background and how you became a maker.
Cool, thank you very much. So first off, I never became a maker. I'm still working on it. But I guess family background also, family of kind of artistic people. My brother is an artist, mega sculptures, painter. I always grew up watching him making really weird stuff and being artistic. But I always wanted to be a designer, like an industrial designer. And I was really, truly discouraged that you should just be a business guy or an engineer. What are you thinking about industrial design? What is that? Is this a job? So I always had these tendencies, but I truly started kind of thinking about electronics, not as a maker, as somebody who tried to solve a problem. I had an iPhone, one of the first iPhones, 3s or something, or 4. And the battery life was like seriously lasting me 3 hours. And I saw these kind of early 2009 battery cases, which are kind of poor and bulky and all that pretty. And I was like, I know I can do it better. Zero background, no EE, no programming background whatsoever, even though I did work for Microsoft at the time. And then that's how I kind of got started. I started thinking about how would a great, charging case look like? How should it behave? Can I automate things? I would order parts from Alibaba and DigiKey and different places and kind of trying to assemble things. And I had all these dreams about solar charged iPhones and buying all these solar panels and all these pieces of glass and assembling them. And eventually I met somebody who's actually an engineer who kind of brought me back to earth. And that's how I got started. We started a little company, we started prototyping, and it's amazing that I haven't heard about Arduino until maybe 2010. I went to a Radio Shack and I told them, what is that? Can't we just prototype with this thing instead of actually doing all these breadboards and expensive PCB runs? And so only later I had this aha moment that we're doing it all wrong today in the industry, that we're building things in such a convoluted hardware where we can actually prototype and get running, and use open source and sharing in communities, which led me eventually to co-found Hackster with Ben Laral, who is in San Francisco sleeping right now. So that's kind of my background, really through a bunch of experiments and trying to solve my own problems resulted in companies, I suppose.
Oh, cool. Okay, thank you for your stories. Actually, so one of the things I wanted to ask our esteemed guests is, since they are prominent members of the maker community in different capacities, is in a way, what do you think is the state of the maker movement? Because there was, when it started, I think there was a huge amount of excitement, and there was a number of things that, the people expected the maker movement to achieve, and a number of them have been achieved. But then now I think it's a kind of a juncture, so something is changing, and I'm trying to understand the question myself. So I have 5 people who are very well positioned to answer that question. So, Leah, why don't you start? You have a lot of experience. You were also at the MIT Media Lab, so you've seen a lot of different variation of the maker movement. Give us your opinion about this.
Yeah, I guess I'm especially interested maybe in tackling one facet of this. I think there are many. I would say as the maker movement has become more widespread and established, particularly in the context of education, it has more, I would say, civic responsibilities. So it has, and it's taking those on, but it's sometimes, I think, challenging and difficult to do so. So for example, here in the United States, the maker movement is increasingly becoming part of public schools and public libraries and kind of public, kind of government funded and supported institutions. And as that happens, it kind of brings to light tensions, I think, within the maker movement, particularly around diversity and equity, how expensive often many of the projects are, how the community has largely in the past been not a very diverse community. And so those things have been brought to the fore in new ways. And so I think here in the States, at least one of the big things that is happening is trying to address some of these issues about how can we truly make it accessible to everyone, where even to people who don't kind of come to the table with lots of resources already. So that's a facet that I'm really interested in and trying to support in a variety of ways, and excited to see progress happening also.
Thank you. Actually, so I wanted to, so Matt, question for you, same question. You are based in London, and you make tools that are used by people all over the world. So I guess there's also an evolution in the way that you do things. No? So you started off as a kind of tool for makers, and now it's used by even companies. So give us your perspective.
Yeah, I think as I was walking here today, I was trying to think what is the most succinct and kind of academic definition of the maker movement. And I think it's like rapid physical iteration with and prototyping with different tools and materials, right? So I think that's the thing that ties everything together. There's a cultural attitude on top of that as well. But what I see from the maker movement is that early on in like 2004 or 5, I saw my first issue of Make magazine, and I remember thinking like, wow, what is this? And it really spoke to me, but I didn't have any cultural context for it. But at that time, the maker movement was diverse in terms of the types of skills that were involved. So you'd have people doing electronics and people doing knitting right next to each other, which was super, super exciting. And that certainly continues, but it feels like the kind of making side of the maker movement now gets transported to other things, even to corporate environments, but they don't necessarily call it the maker movement. It's just that they call it like an innovation lab or a innovation kitchen, whatever they want to call it. It's the same attitude that's inspired by what all of us are doing, and that certainly maps with our company as well. Is that we still sell tons of tools to people who are doing crazy projects, from like interactive books and walls to really esoteric stuff we don't understand when they email us. But companies now, too, are buying technology right out of the maker movement. And I think when you and Fabio introduced the state of Arduino at the beginning of this, we map in a similar way, which is that if you give a tool to someone when they're a student and you make it accessible to anyone, they take it to their professional career as well. And pretty soon it becomes spec'd as something bigger. The key is to maintain the same open and inclusive attitude no matter who you're working with.
Thank you. Yeah, the inclusiveness is also an aspect that we still have to do a lot of work on. So I want to ask the same question to Giorgio Olivero, who is currently, for the last 2 years, been based in Hong Kong and makes regular trips to Shenzhen. So he has a perspective on the maker movement in China. So if you want to tell us a little bit about your perspective of the maker movement, but also give us some insight on what you see when you go to China.
Yeah, and yeah, I mean, the maker movement is here, I would say, is quite extremely different from, what we are used to in the West, right? In Europe and North America. And it's, the first thing that would come to my mind is actually then probably what's happening anyways, also to the maker movement in the West. Like, in China, in Asia, I mean, at least the little bit I see in myself, like it lacks completely the kind of hacker, kind of oppositional counterculture in a way ethos that it was kind of so much also, because at the beginning the maker movement it was kind of this artisanal kind of crafty thing, or I mean it was mainly about access. And kind of, I don't need to ask for your permission to do this, right? And it's just so incredibly empowering. And that was so much of the hacker culture, right? That actually contributed to the whole, I would say, the think about kind of the open source part. And that's probably more, in a way, kind of utility and kind of functional. So it's more here, I would say it's more it's a skill set that might be, again, extremely useful. But we've seen this, Matt just mentioned kind of the innovation kitchen, the innovation labs in the corporation. So, I mean, the kind of, I would say that any kind of smaller, kind of closer-knit community movement, the moment it gets more kind of mainstream, it's necessarily kind of dilute into something where kind of the sharpness of some of the original values get a little bit kind of washed out. And so what I see when it comes actually to the future or to the current state of the maker movement, and I'm extremely interested in what actually Leah mentioned, kind of the inclusivity and the diversity, right? But it's also this kind of big, in a way, blind spot. That's also the sustainability. So how are we actually producing electronics? What's the trade-off? What's the social, environmental kind of cost of that? And also, I think that could be, if we want to just kind of go back to the business side of actually people like, Arduino, Matt, actually make a business from Europe and the US, kind of, I would say that there's probably a chance, right, to push for products that are actually probably more expensive than alternatives that people could easily buy from AliExpress, Taobao, Alibaba. I mean, I do that myself. I mean, it's so convenient, right? It's also quite hard to buy an original Arduino in Asia, honestly, right? So but I do, and so I mean, it's not the greenwashing part, and it's not easy, and so it's also. I think it would be interesting to have companies and communities saying, we know this is not easy. We know that we need to learn how to do this, right? But what's the process? How are we actually producing all the amazing kind of things and bits and platforms that you guys use for your own projects, right? So what's the kind of sourcing and supply chain part? So, I mean, clearly being in Asia and I also been involved with kind of supply chain and sourcing project for a couple of years. So I'm kind of more kind of exposed to this kind of topics.
Okay, wow, cool. Yeah, no, on the how to buy an original Arduino in Asia, we're working on it. I think that's Fabio's job. And the next board meeting will all be about that, I guess. No, I'm joking. Ciao, Fabio. And so, okay. So actually, I want to ask Andy the same question, because you guys obviously supply a lot of the parts to the makers, and you also select them based on what the makers want. So you have another perspective on where the maker movement is and probably where it's going.
Yeah, we certainly do. I think the way I often describe it to people when I have this discussion is that the maker movement is currently going through an extremely exciting transitional period. You know, I like to think of it in three waves. You know, in the 90s, as my fellow panelists said, you know, it was very much that hacker counterculture. As he said, I don't need your permission to do this, and it was massively empowering for people. And then came the more generalized maker movement in the 2000s. You know, the Arduinos of the world, etc. And now I think we've reached a point where the maker movement has become so much more mainstream. I mean, the White House holding maker fairs, for example, there are over 300 maker spaces in the US to date. Crowdfunding with the maker movement, we're nearly at $500 million here. We're talking serious money, we're talking serious awareness. And I think it's now starting to click in the minds of the powers that be. This really is something. This isn't just a small community of people meeting up every now and then to say, oh, look, here's my cool project. This is something that we need to be sharing with the kids, you know, in the schools. This is something we need to get in classrooms. How often do we hear, oh, we're going to have massive skill shortages in 5 years? This is their answer. You know, this is their solution, I should say, to that. You know, we see Arduino, CTC, getting into schools. You know, we've seen the microbit every year 7 in the UK has one now. This is a really, really exciting time for us, and I think we just have to be very, very conscious of, you know, the sort of possibilities that it's going to offer. And as a community, I feel we need to make sure that we are sharing our knowledge, passing our expertise onto the next generation of makers, because unfortunately the general maker movement that are us now, we didn't have that. I think it's very important that we are able to, you know, bring the next generation in and make sure they've got all the resources, experience, knowledge that we simply didn't have.
Oh, well, thank you. So, Adam, you make a platform that's used by 500,000 people to share their projects. So what is your perspective on where the maker movement is right now?
Cool, thank you. And by the way, we're a sister company of Element 14, so combined we have a perspective of over 1 million makers and engineers that you know, often use, I would say, at least 25% of them use Arduino for everything.
Sorry.
No, I'm just saying it's interesting to see kind of like we get this kind of even broader perspective when we look at our data and whatever. But I would just say, I really think that the maker movement is totally mainstream right now, which is an amazing thing. Again, thinking just even like 10 years ago, even like 5 years ago, how far it went. So I kind of break it down to like 4 elements, because that's kind of how I see people interact with our community. So there's action. So now the maker movement of STEM, I think the STEM became STEM because of the maker movement. It's such a big deal. Any country you go to now, they have a little, you know, maker hacker space somewhere in their classroom. It becomes like a thing that everybody just has to have. In parents, if you're like a responsible parent, I'm a parent, I have a daughter, she's 7. You know, I feel like I'm compelled to have these books around my house and Arduinos and Tessels and microbits, and because it feels like you're responsible if you don't do that, if you don't teach them something. So the maker movement in the context of education is a big deal. Then you have enterprise. The enterprise kind of, you know, they fund a lot of us. We can kind of live without them. But the enterprise see this thing, so they got in, they got excited, and now the enterprise just says, hey, how do we make money out of makers? You know, how does this whole maker thing actually is profitable for us? So the enterprise is really important because they are funding and fueling a lot of it, but they also just kind of, they have this other kind of vision. It's kind of like, well, is this a profitable thing we should be part of? And then you have the hackers. The hackers really contribute to the open source. They open everything. They try to kind of push the limits, and they're very important. And then you have the entrepreneurs, and what they're doing is, so they started as makers and they're doing something for fun, and all of a sudden they're like, well, I'm actually not building a product, and now it's becoming a finished product. So you kind of have these 4 elements, but I still feel that the hackers are really, really the core, and they're really important for this whole thing, because they really, hackers are the people that kind of open everything, and they're kind of like the anti-establishment almost, right? So everything from STEM to enterprise to entrepreneurs and everybody who's building stuff is really, really depending on people who keep things open. And if you don't keep it open, what you have is a bunch of patents and closed secrets and things that nobody else can utilize. So full-on mainstream adoption, yes, it has its challenges, but I think the core is still remaining the people that publish, share, and really pushing for open foundries, open foundations, you know, sharing on GitHub, sharing schematics, bonds, everything that they do, because that's where the life comes from. That's the fountain.
Oh, wow. Thank you. That was great insight. Actually, so one of the things, we are kind of going towards the conclusion of this panel, but I have a question because me and Fabio and other people so in Arduino spend quite a lot of time talking to people and asking what they do and what they want to do with technology and where they're going to try to understand really, you know, where what we can do different, how we can do better, what areas of technology we need to explore. So I wanted to ask very quickly, like very short answer from all the members of the panel about give a suggestion to Arduino. So I'm going to start with Leah. You created a whole genre of Arduinos. So, you know, I will start with you. Give us a suggestion, something we should do.
Gosh. That's tricky. So, although one thing immediately comes to mind, it's kind of a new space that I think is really interesting. So I have a brother who's a wildlife biologist. So this piggybacks a little bit on some of the stuff that Giorgio was saying. But there are all sorts of like problems in biology that seems like they could be fruitfully addressed with partnerships between biologists and engineers. And it's kind of amazing to me that that is a kind of integration, a combination that there's very little of collaboration.
Don't freeze.
One of the hugest, one of the biggest problem in the bird universe is tremendous numbers of birds are becoming extinct because of cats. So, and perhaps some of you know this, but cats are #1 kind of leading problem for bird extinctions around the world, like our pets, and the fact that they get outside and they kill birds, like a cat will kill tens of thousands of birds in its lifetime. And this is a threat for biology. And it seems like this is an issue that could be addressed like an electronic gadget cat could wear around, right? Like, why aren't we kind of integrating some of these other fields, the challenges they're facing? And I guess they're particularly exciting in the space of biology and wildlife biology. So I'll leave it at that.
Okay. There was a little problem in the connection, so it dropped a little bit. We get the general gist, but unfortunately we dropped a few words. I'm going to quickly ask Matt.
This is quite an intimidating prospect, and I feel like I should take time because all of you guys are here. It's like speaking truth to power, right? Amazing. I mean, I think that the hardware is crucial, right? Everyone's developing stuff with Arduino because the hardware is really high quality and it's easy to use and the IDE is great and the features are important. But I just would say I hope that Arduino realizes that that's all subservient to the cultural attitude of openness and inclusion and ease of use. So the hardware has to work. That's crucial. But I think for me, the thing that got me so excited about my first board was the possibility that I could do anything because it was so connected and there were so many people who were willing to help, and that must be the focus, and then the hardware can change and the hardware can get better.
Thank you. Giorgio?
Okay, so my advice is actually more of a throwback, kind of back to when actually Arduino was invented. So the success story, I mean, back in the days was actually the driving factor wasn't really the need to find a technology use case, right? I mean, we're seeing that kind of the need for a technology use case with IoT, 3D printing, and all these kind of ways. We've seen that happening so many times in the past years, right? But so, I mean, really, not to find use cases for technologies, but again, just kind of to try to understand what our user needs, right? So back in the days was students, design students that just wanted a leaner, easier, faster way to solve their pain points, right? And so what are the pain points now? And then start from that.
Thank you. So I'm going to change the sequence a little bit. I'm going to ask Adam, because then later Andy has a small announcement to make. So not an announcement, not a small one. So Adam, give me a suggestion. Give us a suggestion.
I think we need a Massimo robot painted with a very conductive and a lily pad head. Kids get to click, and you say really funny things with heavy accents, and we all get to hug it and love it. But I really think like maybe two ends. One end will be the kids. So kids get excited about things when they blink and they have lights, like the lily pad, things that are more interactive. So when we think about STEM, getting into schools and exciting kids about Arduino, something that really, it's more artistic, the artistic flair, it's something that they get connected with. Otherwise, they're kind of like, oh, okay, Dad, and then they kind of give up. So really kind of thinking about that end for children, something that really has that tactile, visual flair to it. And then I think on the completely other end, on people that grew up prototyping with Arduino and loving Arduino, create like a true path to take a micronized, low-cost Arduino board that can be embedded into finished products, you know? And I think this is a little bit something you guys are going with, maybe with a Maker series. So I think on that end, it will make so many people delighted. They don't have to relearn and recreate, and what they use on Arduino as a prototyping tool, a learning tool. Now they have to port it to a completely different platform. They can just take the exact same thing that they know and love and use that as a finished product, at least in low to mid-size, maybe runs in kind of like startup production.
Oh, cool. Thank you. So I'm going to ask Andy to give us his suggestion, and then you have a small, I guess I keep saying it's an announcement. It's a very interesting announcement. So why don't you give us your suggestion for Arduino, and then you tell us about this interesting thing you're working on.
Sure. So I won't make them one and the same. I think, especially with the Maker family, and the diverse range of connectivity that is now on offer, I think there is a seriously good application for smart agriculture, for example. I think for one of the first times, we are now able to take our Maker projects out into the wild. You know, there's now portable power supplies for the Pi, all those kinds of things. We can extrapolate so much data now from nature without too much physical intervention, not having to go out into the fields every now and then, all the time to go and do it. Now it's much less so. I think with things like, LoRaWAN, for example, there are a lot of opportunities and a lot of solutions there that Arduino can really be at the forefront of. I think with the environment being such a hot topic worldwide, from people denying that climate change isn't real to, to people saying we really need to do something about it. I feel Arduino has the presence, the reputation, and quite frankly, the ability to be able to drive a forefront to change things for the better.
So why don't you tell us a little bit about this project that you are working on, which is also a challenge, and it's an interesting design challenge because of the topic.
Sure.
This is interesting.
I'll introduce my fellow colleague from the Element 14 community. This is Phil Hutchinson, and just as we were saying, changing things. Yep.
I get a clap as well.
We're clapping for Phil. Woohoo! Okay.
Just as we were saying, changing things for the better. I'm going to pass it over to Phil. He'll run you through what we've got planned.
Phil, please tell us about this story. It's very exciting.
Yeah, so we are, I'm Phil Hutchinson from the Element 14 community. I'm a member of a big community working with Premier Farnell and Hackster, and we have over 500,000 members. We are launching a brand new design challenge, which is a build challenge, which we are inviting you all, people at university, people at maker spaces, makers of all ages and sizes. We're inviting you all to enter it. It's sponsored by Arduino, which we're super happy about. It's designed for a cause, the design challenge. It's an assistive technology challenge. Challengers are invited to build assistive technology for people with complex needs or disability. And the big deal with this is that all the projects that people are building for a chance to win the prizes, you have to make your code open source, you have to make your projects replicatable, and this is the best part of makers, building something to make somebody else's lives better. On the community, it's a 10-week build challenge, so you have 10 weeks to build what you want, something to help people with disabilities, complex needs. Examples would be, you know, IoT canes for blind people, devices to help people with sensory issues cook better, because that's a hidden challenge. Mobility aids, hygiene aids, all the nitty-gritty stuff with living with a disability of some kind. Arduino have been kind enough to provide us with 15 kits of the Maker 1000, the IoT bundle, which is fantastic, the Proto Shield with the SD card, and the Uno converter kit as well. If you win, anybody can enter, but we are giving the 15 sets to our selected 15 challengers. You don't have to be one of the selected challengers to win, but the winners get $1,000 donated to a charity of their choice, a Fluke thermal imaging multimeter, which is really cool, and the Tinker Kit robotic arm, which is absolutely badass. Wow. Cool. Yeah, they're really nice. Second runner-up gets a $500 donation, a 10-mile handheld oscilloscope, and a micro Arduino drone quadcopter kit. All finishers, those are people that have built a project and posted it on the community with a minimum of 10 blogs in the 10 weeks, will also get $100 donated to a charity of their choice and a set of prizes. Applications open on the 23rd of May, so set a reminder, open a Word document now, start writing down what you want to build. It is open to everyone. All that's required is that you use the Arduino Maker 1000 or one of the newer boards, and post on the Element 14 community, which is element14.com/community. And yeah, help people. Be a maker, be a good maker, and help people with complex needs and disabilities.
I think, thank you for doing this. I mean, this is very interesting because this challenge is actually quite in line with some of the things that we've been saying today. You know, put makers to work to benefit other people, and then share their project as open source so other people can build them. Because actually I think that's also one of the big things about makers, that when we solve problems, we share our projects openly, and then other people can benefit, and this creates like an amazing effect. And so this is also one of the things that's great to be part of this community. So I want to thank all of our guests, Leah from currently in New Mexico, Adam currently in Seattle, Giorgio got disconnected probably by the Chinese government because he was, you know, he was being too open about stuff. So thank you very much for taking part and waking up early or staying up late to join this panel. Thank you to our guests, and thank you very much.
Thank you. Thank you.
Thank you very much.
Thank you.